Okay, so hi there everyone again. Welcome to our set of videos in grade 11 statistics and probability classes. And here we have ended it up in the last video about this example number 4. That is, we have been in the operations with integers, and we're going to answer this exercise here. So the rationalization. Consider the experiment, let me read it again, of tossing two fair coins and define the events. We have event A that talks about two heads coming up and B, two tails come up. What we are tasked to do is to find the union, the intersection. We're going to determine if they are mutually exclusive and find the complement of event A. So with this in mind, we need to first define our sample space, and we need to define this what event A is and what event B is. So please take a note of this example. I'm going to make use of a um, of a sketchpad in the next few seconds. So please take note of that. Let me use a sketchpad now. Okay, so we have talked about that we have an experiment of tossing two fair coins, and we're going to define the elements A and B. First, we're going to talk about the experiment itself of two fair coins. So when you throw two fair coins, we need to first determine the sample space. So our sample space in throwing two fair coins is that we can have either head, H and H, we can have H and tail, head T or HT. We can then get a tail first in the first toss. That's TH. And then lastly, we can get all tails. That is TT. If you have some questions on how this happened, um, I can recall you back to the previous video. I believe that's our second video about this. So if you want, we can make use of the tree diagram here. I'll just make it very fast since we have already done with this. So HT, this is our first toss, and we're going to have HT again for our second toss if you got a head in the first toss. And this also happens if you got a tail in the first toss. So this is our tree diagram. As was illustrated, this is our first toss, and this is our second toss over here. So to determine all the sample outcomes of our sample space, that is our sample outcome, we need to take or consider all the possible outcome, all the possible um, ways that we can get an outcome. So we can get a head in the first toss. We can get a head in the first toss. Hence we have this. We can get a head in the first toss while getting a tail in the second toss. So we can get these. Then we can get a tail in the first toss and then head on the second toss. That's why we got this, and a tail on the first toss. Likewise in the second toss. That's why we have this. So those are all the possible outcomes of this kind of experiment. Next, we want to consider event A and event B. Event A is getting two heads come up. So in this event A, what we have is a set which has one outcome, which is HH. That is where when two heads come up. So this is what we call a simpleton, a set with a single outcome. So we have heads, heads. That's for your A, for your event A. For our event B, what we have is two tails come up. So what we have is for the B, we have tail, TT, tail, tail. That's for our event B. Now, we are tasked to find the union intersection, determine if they are mutually exclusive, and find the complement of A. So first, we need to get the union of A and B. So we write that as in A union B. So how do we answer that? We just simply copy off all the values from A and B without repeating if there are some repetitions. So the answer is simply HH and TT. Okay, so that's our answer for the union. Next is about the intersection. What are the common things or the common outcomes between A and B? Okay, so what are the common outcomes? Clearly, from observing A and B, we can see that there are no common outcomes on between A and B. So hence we say that A intersection B is empty or is equal to an empty set, saying that there's no common outcomes between A and B. Since clearly A is HH, B is TT, so therefore there's no common outcomes between them. So therefore we say since A intersection B is null or is empty, there's no common outcomes between them. So therefore we say that A union B is then mutually exclusive. So A intersection B, okay, is then mutually exclusive. Mutually exclusive. Sorry for the penmanship. Okay, so that's it. They are mutually exclusive. There. So that's our answer for the third question. Determine if they are mutually exclusive. So they are not. Yes, they are mutually exclusive. And we will be finding the complement of A. So how do we write that? We write that as in A complement, like that. Or you may use the A prime if you want to. Say A complement. So what is A complement? A complement. Those are all the outcomes found in the sample space except what is found in A. So all the outcomes except found in A. So what is found in A is HH. So we're going to imagine in our sample space that we're going to delete this HH. So what is left? So clearly what is left is HT. What else? TH clearly. And of course, lastly, we have TT. Okay, and those are the complement. These are the outcomes complement of A. What we want to highlight here is that although A and B are mutually exclusive, they are not complements. That is, if the result of the experiment is not two heads, it doesn't mean that it must be solely two tails. Okay, so that's the important concept that we want to bring in this example. Okay, so let's go back to the slides. So we have our answers here. The sample space is this, our event A is this, our event B is this. A union B is HH and TT. A intersection B is an empty set, therefore A and B is mutually exclusive, which answers our third question. And A complement is equal to this, HT, TH, and TT. Okay, now this gives us to the last parts of our chapter 0, sample spaces and events. We're going to talk a little bit about De Morgan's laws. So let's consider this example. Consider the experiment of tossing two fair coins and define the events. Event A is when two heads come up, and event B when two tails come up. So it's the same thing, the same example as we have shown before. Then we will determine A intersection B. Then we will determine the A intersection B complement, and we will determine the A intersection, A complement union B complement. And then we're going to define with these steps, we're going to define the Morgan's laws after that. Okay, so let's do this. Have a screenshot of this. I'm going to transfer to the sketchpad after a while.